So here's our second example. Okay, I always love when they give me a diagram. I don't have to think one to create one. However, that's not going to be possible with the next second, with the third one, I should say. So we have Roberta standing between two buildings. Okay, so here she is. She's standing between two buildings in a townhouse development. The building on Roberta's left is 10 meters away, and the one on her right is 7 meters away. Okay, so there is a spotlight at the top of both buildings, and the one creates an angle of 68 degrees, and the other one, spotlight B, of 74 degrees. And it asks us which spotlight is closer to Roberta and by how much. Okay, so we are interested in uh, the length, this imaginary length, if she looks up. Now, I have some lengths and I have some angles, but what we do have here is we actually have right angle triangles. Okay, because those buildings effectively create right angle triangles when they hit the ground. So the first thing we're going to do is we're going to add some letters so that we have something in common that we can talk about. So obviously spotlight A, so I'm going to call that A. We'll call this B, and we'll call where Roberta is C, and then we'll give a D for this bottom of this building and E for this one. So I'm going to find side length X first. And if you notice, it's a right angle triangle, so I should be able to use SOHCAHTOA for it. And that means I would label my triangle according to the angle they gave me, which was the 68. So this is obviously opposite. This is our hypotenuse, and this is our adjacent side, not our A side. So I'll just circle that because that's A. So you can see that we have the hypotenuse. We want to find the hypotenuse, and we are given the adjacent. So we're going to use cos. So first of all, I want to tell the person what triangle I'm looking at. So I'm looking at in triangle ACD, cos of a theta equals the adjacent side over the hypotenuse. Now it's a matter of filling in what we know. So the cos of 68 degrees equals our adjacent side, which we know is 10, and the side that we want to find, which is x. Okay, so we're going to cross multiply, and then we're going to divide. So that is dividing by the cos of 68. So x equals 10 divided by the cos of 68. And when we type that into our calculator, we end up with approximately 26.7 meters. Okay, so that side X is 26.7 meters. Now we're going to look at the other triangle. And again, it's a right angle triangle. So we have our hypotenuse, which we want to find. Opposite, I don't know, and adjacent. So again, I'm going to use cos, but it's in another triangle. So I have to tell the person that I'm working in a different triangle. So in triangle, B, C, E, cos theta equals A over H. And again, now we're going to fill in the information we know. So cos of 74 equals 7 over our y that we want to find. Again, we're going to cross multiply and divide. So we're going to divide by the cos of 74. So y equals 7 divided by the cos of 74, which equals 25.4 meters. Now you maybe are surprised that that is actually less distance from Roberta than Spotlight at A. Okay, so don't always let your looking at a picture actually come up with which side is further away or not. Okay, so we're not quite finished because it asks which one is closer. So we can say Spotlight A is is further away, so B is closer, but by how much? So we just have to do the difference. So the difference here is going to equal 26.7, take away our 25.4 for a grand total of 1.3 meters. So my therefore is, therefore, B is closer by 1.3 meters. All right. All right, let's look at the next question. Okay, the next question is another word question. However, this time they haven't given me a diagram. So we're going to go through it. So it says an excavation site, points A, B, and C have been marked. Okay, obviously we have to mark that. So normally what I would do is I'm just going, I have an A, I have a B somewhere, and I have a C. Notice I really don't know how far things are apart. I'm just putting those points. Then it says the measure of angle C is 132. Okay, so that would be the next thing I would do. So I'm just going to put 132. Obviously my picture is not right because that doesn't look like 132. Points A and C, so A and C are 4.2 meters. And points B and C are 5.7 meters. Then it asks how far apart are points A and B. So in fact, what they're after here is they're after this little c. So you should recognize this. This is the Pac-Man situation. Here's his mouth opening up to eat that angle 132. So I know that I'm going to use cosine law. Now, because I only have one triangle involved, I don't have to put in triangle ABC. I could if I wanted to, but since I have my diagram here, I don't have to. If you don't give me a diagram, you better put something. All right, so we have c squared equals the other sides, a squared plus b squared minus 2ab cos of c. Now it's a matter of substituting our information in, so we have 5.7 squared plus 4.2 squared. That's supposed to be a decimal and it doesn't look like it, so it's going to have to disappear. 4.2 squared minus 2 times our 5.7 times our 4.2 and our cos of 132. Okay, now I'll be perfectly honest, when I actually do this, I actually am capable of typing everything in. If you're not on your calculator, then you're going to have to learn how to make it work the way you want. So I end up with 82, approximately 82.168. That is c squared. So in order to find c, it's approximately 9.1. So therefore, it is 9.1 meters apart. Okay, so what you're left to do is a lot of word questions. It might take you a couple days to do it, and that's fine. Really, really important that you draw a diagram. Really important for a couple different reasons. One of the reasons being if you do have an ambiguous triangle, that you're able to recognize it a little bit better if you have a diagram because you see that acute angle. Also, it helps as far as determining what tools you're going to use in order to solve something. Okay, so have lots of fun tomorrow and the next day probably.